There we go. All right, so changing your base, that formula, the change of base formula allows you to write equivalent logarithmic expressions that have different bases. Okay, so in symbols, for all positive numbers a, b, and n, where a does not equal 1 and b does not equal 1, we have log base a of n is equal to log base b of n over log base b of a. Okay, so we're changing this base to a b. Okay, I can take this n value attached to the log base a of n. I would put that one in the numerator. This base of a, I would put in the denominator. Okay, changing it to a log base b. So an example, I have log base 3 of 11. I want to change this to a log base 10. Okay, so I would take log base 10 of the 11 divided by log base 10 of my original base. Okay, so that original base goes into the denominator part of your new base 10 logarithm. Okay, below I have the proof of that formula. So I have log base a of n is equal to x. So we have a to the x is equal to n. Bring in log base b to both sides. Okay, I could bring this x value out front. Divide by log base b of a to get x by itself. And that is how I would get my formula. So the change of base formula makes it possible to evaluate a logarithmic expression of any base by translating the expression into one that involves common logarithms. So since you cannot put in any base into your kind of calculator here, okay, you can in a graphing calculator, but in a scientific calculator you cannot. The only one you have is a log base 10 on your calculator. So we can change any log base to a log base 10. So that's what we want to do so that we can evaluate this log base 3 of 20. So to change log base 3 of 20 into a log base 10 or a common logarithm, I would have, all right, I'm doing an example now. Let's focus, please. Okay, I'm changing this log base 3 into a log base 10. When we have log base 10, we don't write the base 10, it's just log. Okay, I'm going to take my original 20 here and attach it to that log. Okay, that's over. Okay, again, log base 10 or your common logarithm. Again, don't write base 10 of your original base value. Okay, and that would be 3. Okay, so I can change any log base into a common logarithm. I do that because you can enter that into your calculator then. So that's what we're going to do next. So on your calculator, we can type in log 20 divided by log of 3. Okay, to get an answer of about 2.7268. And that's rounding to the nearest 10,000. I was going to say, where did that come from? Okay, so this answer right here is log base 3 of 20. Okay, I had to change it into common logarithms in order to enter it into my calculator. Okay, so if I were to take a graphing calculator and type in log base 3 of 20, I would get 2.7268. Does that make sense? All right, we're going to do another one. Okay, so we want to express log base 6 of 8 in terms of common logarithms and then approximate its value to the nearest 10,000. Okay, so we have log base 6 of 8. Again, I want to change this to a common logarithm, which is log base 10. Okay, so I need to first change that base to just log. should be base 10. We attach the number after in the numerator, so this is 8, over log of the original base, which is 6. Okay, type that into your calculator. Okay, log of 8 divided by log of 6. Yeah. Okay, so I get 1.1606. Okay, so make sure you can get that. Did we get that when we entered that into our calculator? All right, I want you to do 3 and 4. Okay, so express that as a common logarithm and then find the approximate value.
Yeah, but it takes like a while. Yeah, what's up this one? I have one, but like it's lost. Did you get it? Have homework?
Yeah.
Is it anything different than the other day? So that's something. Wait, is it really? You have mine?
Did you finish the problem? Oh, good job. Proud of you. Let me go through these and then you can. Okay, so example 3, how would I set this up as a common logarithm? How do I set number 3 up? Okay, and you should get 2.1337. Okay, and then number 4, we would have log of 9 over log of 4. It's 1.5850. Okay, so again, we're just changing that base so that we're able to enter it into our calculator. If you have not finished your other assignments, when you finish this one, because it is fairly easy and you should finish it in class, you can work on those other assignments as well.
Thank you, Ms. Baldwin. I hope to learn more. You hope to learn more, huh?